In today's lesson, we're going to look at the probability of compound events. A compound event is when you have multiple events happening and you're looking at the overlap of their probabilities. So just to remind you, we have looked at what's called simple probability in the past. So simple probability is when you're looking at just one straightforward event. We looked at the number of favorable outcomes, compared it to the total number of possible outcomes, and that was our probability. So if you were rolling a number cube and you wanted to know the probability of an odd number, there are 3 odd numbers, 1, 3, and 5, out of 6 total possible numbers. So your probability would be 3 out of 6, or 1/2. In our last lesson, we actually started doing some pre-work with compound events when we started looking at multiple events to see if they were independent or dependent of each other. So independent events were when you had 2 events or more, could be more, but they had absolutely no impact on each other. What happens in one event does not impact the chances for the other events. This would be if you were flipping a coin and spinning a spinner. It doesn't really matter what you flip, heads or tails. When you go to spin the spinner, you still have an equal chance of getting everything on the spinner. Or vice versa. If I spin a spinner and get red, it's going to have no impact when I go to flip my coin. I still have an even choice of getting heads or tails. On the other hand, dependent events, they are going to impact each other. So what happens the first time will have an impact on all of the events after it. An example of this would be if you're playing Uno. If you really, really, really need a blue card, but it's not your turn to draw, what the person before you does is going to have an impact on your chance of getting a blue card. If they draw 4 blue cards, you have less of a chance because there's not as many blue cards left in the deck. If they don't draw a blue card of the 4 that they've taken, you have a better chance of getting a blue card because they've taken some of the non-blue cards out of the deck. So you guys are going to be independent. Those events are going to depend on each other for the chances. So as we launch into today's lesson, we have our learning goal of being able to calculate probabilities of compound events. Now, there are many types of compound events, and so we're going to focus on 2, a union and an intersection. So a union probability is when you have multiple events and either one could happen. You can be successful if A happens or if B happens. But with intersection probabilities, they have to both happen. So A and B have to happen in order for you to be successful. So we're going to break these 2 down today, one at a time, and do a couple practice for each one. And we're going to start with union probabilities. So the word union means to join together. So we're looking at multiple events and we're going to join together their probabilities and get one big giant probability. Just a reminder, to be successful, either event needs to happen, not both, but either one. Often, not always, but often, the statement of probability will use the word or. So they will say, I need this or this to happen to be successful. Mathematically, we use this notation. So I want the probability of A, the probability of B, and the U in between means union. So I want A or B to happen. In order to calculate a union probability, we're going to take the individual probabilities and add them together for one big probability. And then here's just a picture that you're going to start to see in mathematics. So I wanted to introduce it to you. This circle is labeled X, and you'll notice it's shaded in. So this is saying that anything in the X circle is considered a winner. Same with the second event, Y. Anything in the Y circle, since it's all shaded in, is considered a winner. Anything outside is not shaded, So you would not win if something happened that's not inside one of these circles. Now there is a warning, and you can see it in the circle. So here's the warning. You may end up counting something twice, and you don't want to do that. You do not want to inflate your probability by putting the same event in more than one time and making it look like it's going to happen more than it actually does. So let's look back at our circles. I said anything in X would be okay, anything in Y would be okay. But if you notice, there's this little overlap in between where there are certain elements that are in both circles. It's part of the X circle and it's part of the Y circle. So when you go to calculate the probability of X, you've counted it here. And when you calculate the probability of Y, you've counted it here. Now you've counted that same little element twice and made it seem like it has twice the chance of occurring when really it only happened once. So when that happens, we need to subtract out one of the ones we've added in twice. Here's an example with some actual data. I'm going to draw a card, and I will win the game if I draw a heart or I draw a king. So it doesn't matter what heart I draw, I will win. It doesn't matter what king I draw, I will win. So if you break those apart, I'm going to look at the hearts, and oh, there's 13 hearts. So I have 13 chances of getting a heart. I have 4 chances of getting a king because there are 4 different kings. So 13 and 4, that sounds like I have 17 chances of winning. However, this king of hearts is only one card, but I counted it twice. I counted it in the heart circle and I counted it in the king circle. So I've made it seem like there are 2 kings when I added them together, when there's really only one king of hearts. So I'm going to have to subtract out one of those extra hearts that I added in. So I have 13, and I really actually only have 3 more chances because I've already counted that king. So I would do 13 plus 4 minus that one that's overlapped. I really only have 16 chances of winning. So just double check. You always want to ask yourself the question, is there anything that belongs to both categories that I've accidentally counted twice? So before we move on to intersection probabilities, pause this video now and go back to your lesson and look at your lesson. There are some examples of union probabilities that you can look through. Try to figure them out and then look at the answer sheet and then come back to the video to learn about intersection probabilities. Welcome back. I hope you got a good grasp of what makes something a union probability. If not, feel free to Google and look around. There's a lot of YouTube videos on this topic. But we are going to move on and look at intersection probabilities. So for an intersection probability, to intersect means to overlap. So we're looking at where these probabilities overlap so that they are both happening. So we're to be successful, both events have to happen. You will often see this, again, often, not always, but you will often see this as a statement of and in the problem. So it will say, I want A and B to happen in order to win. Mathematically, it's very similar to the union notation, except for the U is upside down. This means intersection. So that can get confusing because it's so similar. So I remember U and union go together, so then the upside down one would be intersection. This is saying that you want A and B to be true in order to win. So in order to do this, we calculate it by multiplying the individual probabilities together. So I will find the probability of A, I will find the probability of B happening, and then I will multiply those two together to find the probability of them both happening. And then using our set picture, they have to both happen. So it has to occur in X and in Y in order to be true. If it's just X but not Y, it's not a winner. If it's just Y but not X, it's not a winner. If it's both in this little overlap or intersection, it is a winner. So that go ahead and head back to your lesson now, and you are still going to find the probabilities of the individual events, just this time you're multiplying those probabilities together. So there are again some practice problems that show you some intersection probabilities in action. So you can see the difference between the way questions are worded for union probabilities and the way they're worded for intersection probabilities. Then there's a few for you to try to read and try to figure out for yourself with some answer sites. Have a great day.